Hi students, this is Gaurav Singh and today I am going to tell you about the divisibility rules of numbers because it helps us to simplify the numericals easily. If we are sure about whether this particular number is divisible by certain number or not, then it's easy for us to proceed for the calculation part and gets our answer easily. So all we know that 1 can divide any number and the result is the number itself. But when it comes to 2, we just check the unit place, okay, and if it is 0, 2, 4, 6, 8, then that particular number is divisible by 2. Doesn't matter how many number of digits are there in the entire number, but we just simply check the first, or we rather say ones digit. And why we do so? Because 2 means 2 to the power 1, so here 1 signifies the unit place. Okay, now let's come back to divisibility rule of 3. If the sum of all the digits is multiple of 3, it is divisible by 3, and if it's not, then it is not divisible by 3. For example, I have given you 3435, so we will add separately the 1000th place, 100th place, 10th place and 1's place. That is 3 plus 4 plus 3 plus 5, which sums up as 15, and 15 is multiple of 3, hence it is divisible by 3. That is, what does it mean? That the number 3435 is divisible by 3, and we can say this without actual division. Similarly, the second I have given you 103447. So in this case, if we add 1 plus 0 plus 3 plus 4 plus 4 plus 7, we get 19, and which we know that 19 is not a multiple of 3, rather 19 is a prime number. So here we can say that the entire digit 103447 number is not divisible by 3. Divisibility rule of 4 is also similar to divisibility rule of 2, but the one change in this is 4 can be written as 2 into 2, which means 2 to the power 2. So here by the power 2 we comes to the conclusion that we checks the unit place and tens place. So we take the last 2 digits of a number and check whether the two numbers are divisible or multiple of 4 or not. For example, I have given you 307924. So the last 2 digits are 24, and if I divide 24, we get 6 as a pure integer. So once we get integer, a pure number, that number is actually complete number is divisible by 4. So I have given you here one example, you can cross check. Now getting back to the next number is divisibility test of 5, which is very easy. Either the unit place will be 5 or 0. So that number would be divisible by 5. Now coming to 6, we all know that 6 is like the factor of 6 is 2 into 3. So if any number which is divisible by 2 as well as by 3, it is divisible by 6. It's not that if any number is divisible by 2 but not by 3, or vice versa, like it is divisible by 3 but not by 2. So that number is not divisible by 6. But if it is divisible by both, it is divisible by 6 also. Divisibility test of 7 is quite interesting and we should know. It is a bit different than what we have read in the last 6. For 7, we do take the last digit of the entire number and we multiply it with 2. Then we subtract that result from the remaining of the number and check whether it is in the multiple of 7 or not. For example, if you see here, I have taken the number 343. So 34 minus the last digit is 3. 3 into 2 gives us 6. So 34 minus 6 gives you 28, which is 7 into 4. So you can say yes, it is divisible by 7. If you further want to check whether 28 is divisible by 7 or not, so you can do one thing. Pick the first number 2 and the last digit at 8. So 2 minus 8 into 2 gives you 2 minus 16, which is minus 14. So the difference should be the multiple of 7. And we all know that 7 2s are 14. So it is conclusive evidence that yes, this particular number is divisible by 7. Now, divisibility test of for 8 is like, again I say it, just like 2, 4, 8 is 2 into 2 into 2, that means 2 to the power 3. So here 3 signifies to us as take the last 3 digits of the number and divide it by 8 and check is it coming as a perfect integer or not. if it reflects or gives back you perfect integer, that entire number is divisible by 8. And if it is not, it is giving some decimal value or fractional value, then that particular entire number is not divisible by 8. Divisibility test of 9 is also, we check the sum of all the digits in the entire number, and if it is a multiple of 9, then it is divisible by 9. Okay. Now, for example, I have given you 2565, and when I add up all the digits, 2 plus 5 plus 6 plus 5, it returns me 18, which is the multiple of 9, as well as 1 plus 8 gives us 9. So yes, it is conclusive that this particular number is divisible by 9. Divisibility by 10 is very easy. It just, we have to check that the last digit is 0 or not. If it is 0, yes, it is divisible by 10. If not, it is not. Now, if we have to check divisibility rule by 11, we have to first address the positional values of the digit, and we will differentiate it between even place and odd place. So the very once digit place, we take it as an odd place value, the tens place as even place value, hundreds as odd again, because 1, 2, 3, 4, 5, there are 5 digits, and from the rightmost, if I start marking it as 1, 2, 3, 4, 5, so the first, third and fifth term will be your odd position values, and numbers on the second and fourth position even position values. So we take the sum of odd place values and sum of even place values, and then we try to find the difference of both the result. If that result comes as 0 or multiple of 11, then particular entire number is divisible by 11. If it does not comes like 0 or 11, then that number is not divisible by 11. The next number is 13. For 13, we do take the last digit and multiply it with 4, and we add it with the remaining number of digits. And if we check the result, is it coming in the multiple of 13 or not? If it comes as the multiple of 13, the entire number was divisible by 13. And if it is not coming so, it is not divisible by 13. For example, I have given you 169, which we all very well know that it is 13 square. So it must be divisible by 13. But let's check it by the divisibility rule. So the last digit here is 9. And if I multiply 9 by 4, it gives me 36. Plus 16 gives me 52. And we all know that 13 fours are 52. Hence, by this method also we can say, by looking at the number, that 169 is divisible by 13. Now divisibility rule of 17 is, I take the remaining number and I subtract it from the last digit multiplied by 5. For example, I have the number 289, which we all know is the 17 square, 289, so it must be divisible by 17. But let's check by this method. 289 is a 3-digit number in which the last digit is 9. So if I take away 9, the 2 digits remaining are 28. So 28 minus 5 into 9 means 28 minus 45, which gives me minus 17. Actually, when we are getting the result of difference in negative integer or positive integer, we just have to take the positive value. Means we are trying to find out the difference. So since it is coming 17, so we all know that 17 is a multiple of 17. Hence it is divisible by 17. Another example which I have taken is 11,289. So 1128 minus 5 into 9 gives me 1128 minus 45, which is 1083. And again, if I am trying 1083 minus 5 into 3, it's not getting the multiple of in the form of 17, because the result is 93, and we know that 17 5s are 85, and it's not near to 93. It will give me some decimal value. Hence, even if you check cross and you try to divide 11,289 by 17, the result will be 664.05. Hence, by this method we can say particular number is divisible by 17 or not. So hope you are clear with the divisibility rule of numbers from 1 to 17, and I will try to upload in the next video about the divisibility rule of 31 and all those numbers 41, 47. Till then, take care, bye bye. Make your life easy with the easy calculation methods.